Launch Director.
Launch vehicle is ready for launch.
We have ignition.
You have permission to launch.
1, and liftoff. Liftoff of the United Launch Alliance Atlas V rocket.
Mach 1, execute. And we have an indication of spacecraft separation.
Atlas engine ignition.
At Space
0.
Launch Complex 41, an Atlas V rocket is fueled and ready to launch the NROL-101 mission for the National Reconnaissance Office. Good evening, and welcome to Cape Canaveral Air Force Station in Florida. I'm Dylan Rice, a Systems Test Engineer, Launch Conductor, and the host for tonight's broadcast. Liftoff is set for 5:24 p.m., and the team is not working any issues at this time. Shortly, the count will enter a planned 7-minute hold. We have 2 planned holds in today's nearly 7-hour launch count today. These holds give our team additional time to resolve any issues prior to entering the terminal count. However, at this time, the team is not working any issues, and we are proceeding towards an on-time liftoff at 5:24 p.m. At the request of our customer, today's live coverage will conclude following payload fairing jettison, scheduled to occur about 3.5 minutes after liftoff. In addition to watching our webcast, you can also follow live mission progress at ulalaunch.com.
Empty.
Jessica Williams, the 45th Space Wing's Launch Weather Officer, recently briefed the team on current conditions here at Cape Canaveral. The probability of violating launch constraints is less than 10%. The ground winds are 10 to 16 knots out of the north, and the temperature is 75 degrees Fahrenheit. With that forecast, the weather is within launch commit criteria and looks favorable for our planned T0 of 5:24 p.m. Eastern Time. This afternoon's flight will fly a northeasterly heading away from Cape Canaveral. Let's take a look at what else we can expect to see.
Atlas engine ignition 0, and liftoff of the United Launch Alliance Atlas V rocket.
The Atlas V RD-180 engine and 3 solid rocket boosters ignite and generate nearly 1.8 million pounds, or 8 million newtons of thrust, to lift the rocket off the pad. Shortly after liftoff, Atlas begins a pitchover to attain the proper flight path while minimizing the dynamic pressure the vehicle experiences during flight. The Atlas V reaches Mach 1, the speed of sound, at 39 seconds. At 1 minute 34 seconds, the 3 SRBs burn out. Jettison of the first 2 SRBs occurs at 1 minute 54 seconds, followed 2 seconds later by the remaining SRB. In the next 2.5 minutes of first stage flight, the Atlas V will more than triple its velocity. Approaching payload fairing jettison, the Atlas V is burning propellant at a rate of 1,700 pounds, or 770 kilograms per second, traveling more than 7,800 miles, or 12,500 kilometers per hour, and located 73 miles, or 118 kilometers in altitude, and 135 miles, or 217 kilometers downrange. During ascent, NROL-101 is protected inside a 5-meter diameter payload fairing. This two-piece shell encapsulates both the Centaur upper stage and the spacecraft. Once the vehicle has climbed above the densest part of Earth's atmosphere, the payload fairing is jettisoned. Following payload fairing jettison at 3 minutes 19 seconds, the Atlas V rocket continues on a classified mission to space.
ULA is using an Atlas V 531 rocket to launch NROL-101. This is the 86th Atlas V launch and ULA's 141st mission. Atlas V is built in Decatur, Alabama. Atlas V is made up of a Common Core booster powered by an NPO Energomash RD-180 engine and a Centaur second stage powered by an Aerojet Rocketdyne RL-10C1 engine. This vehicle is equipped with 3 Northrop Grumman solid rocket motors and a 5-meter payload fairing. Events began September 9th when the 107-foot-long Atlas V booster was lifted onto the mobile launch platform at the VIF, or Vertical Integration Facility. Next, SRBs were mated to the booster, as shown here. The pre-assembled interstage adapter, Centaur upper stage, and lower half of the payload fairing were added. And stacking was completed on October 26 when the encapsulated payload fairing, shown here, was mated to the Centaur. An Atlas V launch countdown begins with moving the rocket from the VIF to the pad. 6 components are used for that 20-minute trip that's about 1/3 of a mile. We use the MLP, which weighs about 2 million pounds. It supports the rocket and contains air conditioning, electrical, and commodity lines. Undercarriages are used to bear the weight of the MLP and rocket. At the head of the train are 2 rail cars made up of the payload van, which provides spacecraft communication and accommodations, and the ground van, which provides support for the rocket. At the rear of the convoy is an environmental control system that provides air conditioning to the payload and rocket. We use 3 trackmobiles to power the 3 million-pound convoy. The Atlas V stands 206 feet tall, or about 60 meters, and weighs more than 1 million pounds, or 489,000 kilograms, fully fueled. Today's launch is for the National Reconnaissance Office, or NRO. This is ULA's 29th NRO launch.
The NRO is a joint organization engaged in the research and development, acquisition, launch, and operation of innovative overhead reconnaissance systems necessary to meet the needs of the intelligence community and the Department of Defense. The NRO is recognized for transformational intelligence collection systems used to develop highly accurate military targeting data, support international peacekeeping and humanitarian relief operations, and assess the impact of natural disasters.
The payload fairing on the Atlas V rocket carries a few special pieces of art.
L3 primary steering file, adjust_AV090_05.
As they do for every mission, the NRO provided unique artwork. The NROL-101 patch pays tribute to the Lord of the Rings stories with a gold ring and elvish script that translates to "Goodness Persists." The new Space Force Delta logo is also flying on the Atlas V.
T-minus 15 minutes.
Here are some live views from Complex 41 as we move closer to our planned T0 at 5:24 p.m. Eastern Time. Clear blue skies in the background with just a few clouds after Tropical Storm Ada made her way through town earlier this week. Here's a broad view of Complex 41.
Go ahead. First step, 750. You have an estimate.
You can see the large liquid oxygen sphere on the right-hand side of your screen.
I am
The Forts Hall lightning protection towers surround the Atlas V rocket, mobile launcher, and the crew access tower. And fuel farms over to the left side of the screen. More prominently featured here, the MLP and the crew access tower with the Atlas V vehicle ready to go.
We're going to make the 15 minutes once I reach 99.8%.
What, that 15 minutes?
At Complex 41, an upgraded acoustic suppression water system will be used for the first time today. ULA's Ron Fortson gives us a preview.
Hello, I'm Ron Fortson. I'm the Director of Program Management Integration here at ULA. I'm standing here underneath the launch deck where soon we'll have the Atlas V rocket carrying the NROL-101 mission showing up here at the pad. When we launch the rocket, the ignition from that rocket causes a lot of noise. The noise is so loud that it can damage your ears. It's also loud enough that it can damage the payload or a launch vehicle when we launch. So we have to use a water suppression system to help dampen out the acoustics caused from that ignition. The acoustic water suppression system we use here at Launch Ops consists of 3 sections. There's an upper section that's part of the MLP, a lower section, and then there's an exit section that's also part of the system. All 3 of these sections deliver about 2,000 to 3,000 gallons of water per second for a total of about 100,000 gallons. When we light the engines, essentially the system kicks in at T-minus 6 seconds with the lower section starting to spray water. Then the duct section will start to spray water at T-minus 5 seconds, and then 4 seconds after launch, the upper section will start to spray water. It'll continue to spray water for 15 seconds after launch. We made some modifications here to accommodate the Vulcan rocket when it shows up here. So with the modifications we made were to add additional sprayers to the lower section you can see behind me here so that we can further damp out some of the acoustics that are caused by that rocket engine. So we're really looking forward to the upcoming launch here on 101 because it'll be an opportunity to see how this system performs.
Here are more views from Complex 41 as the Atlas V stands ready to go. Prominently featured there on the lower part of the vehicle are 2 of the 3 solid rocket boosters that this vehicle is equipped with. Today's Atlas V will be the first to use solid rocket boosters produced by Northrop Grumman. Let's learn more about the GEM 63 solid rocket booster.
Hi, I'm Taylor DeYoung with Northrop Grumman. Here in our M508 rocket manufacturing facility, we fabricate the nozzles for our graphite epoxy motors. GEM 63 strap-on boosters are solid rocket motors that provide the rocket's initial thrust at ignition and liftoff from the pad. These motors are connected to the outside of the rocket and burn for about 100 seconds before detaching from the launch vehicle. We've been developing and producing these strap-on boosters since the early 1980s, and we've continued to improve and expand upon our GEM motor family ever since. The first strap-on motors used heavy steel cases, but we found a way to make them stronger and lighter with a graphite epoxy winding process. Our early GEM motors successfully flew on hundreds of Delta launches over the years. Today, our GEM 63 motors support ULA's Atlas V launch vehicle. Northrop Grumman is continually evolving its rocket motor products through updated technologies, materials, and processes, and the GEM 63 motor is no exception. We are proud to support ULA and the U.S. National Reconnaissance Office to launch the nation's most critical national security payloads. We're excited to see the GEM motors in flight.
The NROL-101 mission is dedicated to our friend and colleague, Mike Ellis. Let's listen into the dedication.
Today's NROL-101 launch has a dedication on the launch vehicle to Michael Thomas Mike Ellis, who passed away at 60 years of age on 17 September 2020. Mike dedicated more than 35 years of his life to supporting national defense. Mike will be remembered by his colleagues in the NRO for being the driving force behind the design and construction of the Eastern Processing Facility at Cape Canaveral, Florida, the world's premier spacecraft processing facility. The words cemented on NROL-101 read, "In memory of our colleague, friend, and patriot. May he rest in peace."
We often get questions about the various clock displays visible in the Launch Control Center, most notably the T count and L count clocks. T simply stands for time, and L stands for launch. The T count is a scripted time until T0. All of the launch vehicle's countdown events are procedurally sequenced to T time. The L count is the total amount of time until launch, which is the T time plus the built-in holds. Built-in holds are placed at strategic points in the countdown, for instance before cryogenic loading and before the terminal count and liftoff, and are contingency time that the team can use if needed to catch up in the event of a delay in countdown activities. The Atlas mission uses two 15-minute built-in holds for a total of 30 minutes of hold time, which means that the L count starts out 30 minutes longer than the T count. After the first built-in hold, there is only a 15-minute difference between T and L counts, and when we enter the terminal count, the L and T counts are equal. Preparations today took a little bit longer than expected, and so we did borrow some of the time from that final built-in hold for the pre-cryogenic hold, which left us with a 7-minute terminal count hold for today's mission, which we'll be entering very shortly.
LC-1AC. Radar brief, the Centaur locks has gas indicator.
DNet 1.
MD's on 1.
Proceed, AC.
Okay, the team reviewed the ARB that was held to discuss this issue. We did today again violate the 4% of the TRD. However, the ARB did give justification for up to 8% of O2, 2% H2. We are within those limits, and we recommend proceeding.
LC concurs, LD.
LD concurs.
MD.
MD concurs.
LC step 800. All secondary decoms verified on RF link.
Roger.
T-minus 6 minutes.
LC, LD on 1.
So LD.
Please coordinate a new T0 of 22:32.
Copy 22:32 total.
Good copy. Atlas LO2 at flight level.
Roger. RC, LC, net 1.
RC.
Please coordinate a new T0, 22:32.
Copy 223200 Zulu inward.
T-minus 5 minutes. LC locks 2.
Go.
Centaur LO2 at flight level.
Roger.
LC to flight control.
Okay, we just heard the launch director direct the launch conductor to set up for a new T0 of 5:32 p.m. Eastern Time. We will make that adjustment when the clocks enter the built-in hold here in just a few moments, about 30 seconds from now.
Roger.
T-minus 4 minutes and holding. This is a programmed 15-minute hold.
LC switch to not ready.
LC, ALC.
Go.
Countdown clock has been set for new T0 of 22:32 Zulu.
Roger.
LCRC 1.
Go RC.
Range is approved 2230 Zulu T0.
That was 2232.
That's good copy.
All right, team, clocks are set. We have an approved T0 of 2232 Zulu. Currently approaching L-minus 17.
And as you just heard, Launch Conductor Scott Barney verifying the team is now realigned to the new T0 of 2232 Zulu time, which equates to 5:32 p.m. Eastern time. That puts us at just over 17 minutes prior to liftoff. The next major milestone will be the terminal count status check, and that'll be occurring in about 10 minutes. As I mentioned earlier, today's launch is ULA's 29th for the NRO. Let's take a look at the huge role the NRO plays in the security of our country.
T-minus 3, 2, 1, 0. Ignition.
We are the agency that made the impossible possible, protected the world, and brought technology to levels undreamt of.
Go Atlas, go Centaur.
The race to space was a series of firsts, and we were there. We were the first to surveil our adversaries from the high ground of space, literally taking technology to new heights, watching our adversaries, guarding against the threat of nuclear war, and providing strategic advantage to our nation. We were the agency no one had heard of, because we worked in total secrecy. But we've stepped out of the shadows, and we are writing the next chapters of American space technology. We are the National Reconnaissance Office, the NRO, the world leader in our tradecraft, collecting top secret imagery and signals from space. Natural disasters threaten thousands of lives. Conflicts displace millions, and adversaries mount threats. We give advance warning, aid in the aftermath, protect our citizens, and safeguard the world. We are the only agency that develops these tools, partnering with the intelligence community, the military, possible by miniaturization, reducing costs and expanding possibilities. Large satellites with capabilities designed to answer our toughest national security questions. Pioneering achievements on the ground, where analysts bring it all together. How do we do it? By investing in the latest research and development, using augmentation, automation, machine learning, and artificial intelligence, employing acquisition strategies to encourage competition, enabling us to work with the industry's best and brightest, like-minded people, committed to technology without limits. This is where careers rise to heights unimagined, where you can take your eyes and ears into space. We deliver, under budget and on schedule, meeting and exceeding expectations, to answer questions yet unasked. We develop new technologies every day and put them to use in record time in the high ground of space. No one can match us. The National Reconnaissance Office, the world leader in intelligence gathering. We are the NRO.
LC, Fuel 2.
Go Fuel 2.
First step 860, Centaur LH2 at flight level.
Roger.
LC, Peony 2.
Go.
Step 760, Centaur LH2 SVV cycle tests are complete.
Roger.
L minus 11 minutes.
All right, team, this is LC on net 1. We are complete to operations for Operation 50, picking up in Operation 60 and working for the clock.
All communications switch to channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
Terminal count briefing. If a condition exceeds a launch constraint anytime after the terminal count status check, the observer shall announce hold, hold, hold on channel 1, identify the station, and briefly state the reason for the hold. Flight control, perform launch on time verification.
Roger.
OSM, place SRB ignition SNA switch in the enable position. And you're coming through kind of weak on that one.
SRB ignition enabled.
Roger. Blocks 2, verify CISA purge flow, flowing GN2 to the CISA.
Verified.
OSM, verify the FCO, RCO, and OSM hold fire switches are in the pro.
In a few moments, Launch Conductor Scott Barney will poll the launch team for the final go to pick up the countdown. 29 engineers and managers are polled for system status and readiness to proceed. This is the final status check for all ATS vehicle systems, ground systems, the spacecraft, and the U.S. Space Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Scott Barney performs the final polling here in about 30 seconds.
LC switch to the ready position. All steps are complete prior to the status check.
L minus 8 minutes.
And my apologies, we are now about 30 seconds away from that final status check occurring.
Status check to proceed with terminal count. Respond go, no go. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Pasgas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
GCQ.
Go.
GCQ Net 1. Engineer.
Go.
Anomaly Chief.
Go.
Range Coordinator.
Clear to proceed.
Launch Director.
Launch vehicle is ready to launch.
Mission Director.
You have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 2232 Zulu.
Verified.
Polling is complete. The ULA launch team and the NRO mission director are go for launch. From T-minus 4 minutes until launch, you'll be listening to Scott Barney and his team performing the final steps in the countdown procedure. You'll hear the team call out that topping has been secured, followed about a minute later by the call out for transferring the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1:55, the team will command the launch sequencer to start, followed shortly by securing the Centaur liquid hydrogen and Centaur liquid oxygen topping activities. At T-minus 1:40, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, Atlas tanks will be verified at flight pressures, followed by a verification of Centaur tank pressures. A final status check of Atlas, Centaur, and NROL-101 readiness is conducted at T-minus 25 seconds. At T-minus 3 seconds, the RD-180 engine will roar to life. After liftoff, you'll hear the voice of Rob Kesselman providing launch vehicle ascent data.
Copy. Not it here.
You're on Net 1.
This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
On my mark, the time will be T-minus 4 minutes and counting. 3, 2, 1, mark.
The countdown clock has resumed, and we are go for launch at 5:32 p.m. Eastern
Ground
Time.
gyros enabled.
T-minus 3 minutes.
Securing LO2 topping.
Atlas tanks to flight pressure.
250.
FTS internal.
The Atlas tanks are now pressurizing for flight, and the flight termination system is on internal power.
$159.
Vehicle internal.
$155.
Launch sequencer start.
$150.
Securing Centaur LH2.
Securing Centaur LO2.
$140.
Launch enabled.
$137.
FTS armed.
$120.
OCU's armed.
FCS count started.
$115.
Reduce ECS for launch.
Roger.
$110.
Vent valve locked.
T-minus 1 minute.
Rock, report range status.
Range green.
The launch vehicle, payload, ground systems, and eastern range are all go for launch.
T-minus 40 seconds.
Label at step 3.
$28.
ECS reduced for launch.
Roger.
$25.
Status check. Go Atlas.
Go Centaur.
Go NROL-101.
With that call, the NROL-101 mission is ready to launch. T-minus 10,
10,
9,
9,
8, 7, 6, 5, 4, 3, Atlas ignition, 2, 1, 0, and liftoff. Liftoff to the Atlas NROL-101 mission for the National Reconnaissance Office. You are hearing the voice of Rob Kesselman providing launch vehicle ascent data.
Roll maneuver.
Party 180 has gone to closed loop engine control. Atlas has now completed its pre-programmed switchover maneuver. Now at 28 seconds into flight, Atlas is 2 miles in altitude, going at 1,200 miles per hour. Party 180 has throttled down slightly as expected. Engine response was good. Party 180 past Mach 1. Engine pump speeds and injector pressures are in family for this thrust level. SRBs look good. Party 180 has throttled back up as planned. Mach 2. Now 70 seconds into flight, Atlas is 10 miles in altitude, 5.9 miles in altitude, 2,100 miles plus. Atlas has passed Mach 3. Standing by for SRB burnout. We have burnout on all 3 SRBs. Standing by for jettison. The RD-180 is now throttling down slightly, and we have jettison on all 3 SRBs.
Okay, all personnel Net 1, start system securing for Operation
Vehicles
7.
now past Mach 5. Approximately 2 minutes remain in the Atlas booster phase of flight. This time, booster tank pressures look good. And booster battery voltages remain in their expected range. RD-180 continues to operate as expected. Centaur reaction control system is now pressurizing to flight level. We are now 3 minutes into flight on the L-101 mission. Atlas is now 66 miles in altitude, 125 miles downrange, traveling at 7,500 miles per hour. We're now throttling down in preparation for payload fairing jettison. And we've had successful payload fairing jettison and successful CFLR load deck jettison. Atlas is throttling back up after the separation events. Atlas has reached a 4.6 acceleration limit.
Though they look the same, this evening's Atlas V rocket lifted off with new solid rocket boosters. Program leads Jamie Umshed and Samantha Suarez recently sat down to discuss the new SRBs. Let's take a look.
Hi, I'm Jamie Umshed. I am the Vehicle Systems Engineer for Vulcan Centaur program at United Launch Alliance. Prior to this role, I was the integration lead for the GEM 63 program. With me today is Samantha Suarez, Systems Engineer and Integrator. Together, we led the integration program for the GEM 63 on Atlas V. NROL-101 will be the first mission to fly those SRBs. Under a strategic partnership, Northrop Grumman was chosen to be the sole provider of solid rocket boosters to United Launch Alliance for our family of rockets. It's a lower cost alternative to the SRBs that have been flying on Atlas V since 2003.
So one of the interesting parts or challenging parts of integrating these motors is you have to be able to swap out the SRB and make sure you're not increasing risk to the Atlas launch vehicle, and additionally that you're meeting system performance requirements. The main thing was setting a really strong requirements foundation, working with our system level teams and ensuring that we flowed system level requirements down to the design requirements and that the supplier built to those. Also understanding with those requirements which ones did have some flexibility so that when we ran into challenges as we were developing these motors, we could react appropriately, and understanding verification of those requirements.
Northrop Grumman would go through incremental design phases for the motors. They started with a system requirements review, then progressed into preliminary and critical design reviews. Every step of the way, our government customer was a partner in that process. Once you get through your design phases, then you get to go do the fun part, test.
So there's a lot of different phases of testing. So you'll have some early on development testing for like proof of concept. You get into component specific stuff. For the SRB itself, there's 2 major tests, structural and performance. Structural, we did what was called super proof, where you pressurize the case and you apply loads on it and ensure that the case functions as intended when it's under load. Then you have static fire, which is how you validate the performance of the motor. Static fire is unique for solids in that with an SRB, you don't get to fire it before you fly it, so the qual is crucial.
After the flight of L-101, we will actually be transitioning the Atlas V over to GEM 63s after 2021. Same year, 2021, we're going to be flying the first Vulcan Centaur, and Vulcan Centaur will use the larger, more powerful variant of the motor, the GEM 63 XL. Flying the GEM 63 first on Atlas gives us an opportunity to have more confidence in that first flight of Vulcan Centaur, and it also allows us to reduce the cost of the Atlas V and make it more competitive in the launch market. I was on the program for 4 years, and I don't know about you, but I'm pretty excited.
I am so excited, and I know we're not the only ones. There's a ton of people from ULA, Northrop folks, and the U.S. government that were all key contributors to this program, and I'm definitely ready to see them fly.
My thanks to Rob Kesselman for his participation in today's broadcast. Stay updated with the mission on ULA's live blog at ulalaunch.com or join the conversation on social media. Before we sign off, we'll take you to another look at liftoff, which occurred at 5:32 p.m. Eastern Time. I'm Dylan Rice on behalf of the ULA launch team. Thanks for joining us and have a great evening. With that call, the NROL-101 mission is ready to launch. T-minus 10, 9, 8, 7, 6,